All right, problem number 81. So again, the things that bothered me is the things were in kilometers per hour and our stuff was all done in seconds or meters. So we had to convert miles per hour to meters per second. So very first step, so we had 25 kilometers an hour and we needed to convert it to meters per second. So basically, we just multiply it by one, two different times. Our first one is an hour over 3,600 seconds. Our second one is 1,000 meters over 1 kilometer. Notice that the kilometers cancel out, the hours cancel out, and the units we're left with is meters over seconds. So 25 kilometers an hour is approximately 6.94 meters per second. 80 kilometers per hour with the same bit is 22.2 meters per second. So now in the question, they said acceleration is a constant. So I just set acceleration equal to some constant. We'll call it K for right now. So if we integrate once, we find velocity. So the integration of K is KT plus VO, where VO stands for initial velocity. In our problem, it said he accelerates from 25 kilometers per hour to 80 kilometers per hour. So the initial velocity was the 25 kilometers per hour, which again, we had to convert to 6.94. So this is our initial velocity, the 6.94. So the second thing it said was at 13 seconds, his velocity was now higher. It was now the 80 point, the 80, which is 22.2. So basically, velocity evaluated at 13, which we had to plug in a 13 everywhere we found a t. This is our plus the initial had to equal the ending velocity, which was 80, which the conversion is 22.2. You do the math, you subtract 6.94 from both sides, you divide by 13, you get approximately 1.18 meters per second squared for K. Now it asks for how far did he travel? Well, how far did he travel means you got to put in that time, that 1.18 meters per second squared in for acceleration, and you've got to do one more integration. So if I integrate now, V of t is equal to 1.18 t plus 6.94. 1.18 turns into 0.59 because of the whole bit with you had to bump to the 2 and multiply by a half. 6.94 gets a t added to it and plus SO. SO, we're just going to consider that starting point was 0, so we just left it out. So now I had to find P of 13. P of 13 would be 0.59 times 13 squared. Everywhere we find a t, 13 goes in. Worked out a couple things in, about 190 feet. So again, we'll just say I'm sorry for assigning this one, but the conversion was the main pain in the butt, and sadly we had to work with some decimals. But other than that, not horrible. Thanks.